I'm going to write the correct answers down. You check your homework. See if you got these right. I'm going to point out a few little details. After that, I'll go over the answers to 3 through 14, the ones you're supposed to do on here. Then we'll do 2 more radical problems off of the radical sheet. Then I'll pass back your tests and you can start on test corrections within your groups. That's all we're doing today. Standard form. I'll do the whole column. If I circle something, you circle it. If I underline something, you underline it. Oh, you need it. Got it. Take a look at the first column. For the rest of the year, you guys have to pay attention during the lesson. You know you're going to have plenty of time to talk and work it in your groups. Yep. Yep. The ones I put in blue are the ones that people are getting wrong. They're not combining their like terms. Make sure you combine your like terms. 11x minus x is 10x. So I put that blue. And when people are moving things around, they're leaving the negative sign behind. If that's a minus a in number 7, then it better be a minus a when you move it to the front. Keep the sign with the term. That is considered standard form, yes. Yes, we're putting the biggest exponent first. When you have multiple letters, it's considered good form to put it alphabetically. I mainly want to see the exponents, the bigger ones first. They call it descending order. Yeah.
Number 7, you had negative a plus 4. Okay, so there's no exponents, but the letters go first.
Correct. That's considered good form. That's considered standard form. Degree. What do you write down for degree? Which the biggest exponent? I see it 2.
3, 2, 4, 3, 5, 1, 2, 5.
If you don't see an exponent, there's actually one there. 5, 4. Whatever the biggest one is. That's just vocabulary. That's to make sure that when you get an SAT question that says, what's the degree of this equation, you're able to answer it.
Trinomial. On the left side. Monomial. Trinomial. Try. He wants to hear it. He wants to hear it. I asked him if he could read. Oh,
And which one did I write in red?
Monomial.
If you only have one term, that's a monomial.
Monomial.
That's the one that trips people up on tests. Is that part easy?
Yes.
That's the easy part. It's the last part where we have to actually do the like terms. The hard part is just the subtraction. Everybody look over here. We did this last time, we're going to do it one more time. If you see subtraction of a bunch of stuff, here's your bunch of stuff right here. Minus 3x squared minus 5. In number 16, you have 3 things that you're subtracting. Is there any other subtraction down here? 15. What I recommend you do is circle the subtractions.
19.
Do that before you do any of this. Come down to 19, circle that. By doing that, you make sure that you are going to change them to their opposites. Everything else stays the same. If you're adding, like in 11, 13, 14, you just keep it. What I'm going to do for number 12, I keep the beginning. What's the opposite of negative 3x squared? Positive 3x squared. What's the opposite of minus 5? Now it becomes like all of the other problems. Now it's just like terms. And what's
3x
3x squared
plus 9x plus 7.
plus 7? Where did the 7 come from?
2 and 5.
2 and 5. So all of the subtraction problems eventually become addition problems. The first one, it's already addition. I don't have to change anything. 7a plus 1. Next one, we have 10xy.
5x plus 2y.
If you have a minus sign in front of an x, what's actually in front of it? Put a little negative 1 there.
Oh, that's what you mean.
It's actually negative 1. So when I take the 6x plus negative 1x, I get my 5x. You can only combine. You can only combine things that look exactly the same. Is xy the same as xy? You can combine them. You have to have the same exact exponents and letters. So I can't combine a 6x with a 4xy. It's apples and oranges, 2 different ideas, 2 different things. What did you get for 14 when you had the x squared and the minus x squared? What happens to the x squared? They're gone. You're left with 2 of the y squares. For some reason, you guys are changing the exponents. We're not doing that yet. This is still addition and subtraction. When we start multiplying and dividing, then you're going to start changing those exponents. Down here, I see 6p squared plus 4p plus 5. If there's subtraction, I want to see this second line. I want to see you change 2p squared to minus 2p squared. I want to see you change minus 5p to plus 5p. I want to see you change plus 1 to minus 1. Hey, ladies. Then I want you to show me the last step. Now combine everything. This will be 4p squared, 9p plus 4.
Yep.
Watch my arithmetic. It's very easy to make a little mistake. I'm subtracting. Ethan, what do I do when I subtract the number 16? Why did I circle that?
Shut up, I'm lost.
I got to change everything in there to its opposite. What's the opposite of minus xy? Opposite of minus 2x squared. The last one. Now, it's just addition. I add up what I have. Do I have anything to go with the 6x squared?
Yes.
2x squared. So that's x squared. Do I have anything to combine with 5xy?
1x1.
There's a 1xy there, so I get 6xy. How about minus 2y squared? What's negative 2 plus 4? Plus 2y squared. That's as far as you can take it. The reason we do this is so that you can do this when you get to your physics class later on. And these equations actually go with gravity or forces. We live in a three-dimensional world, right? We have length, width, and height. We're not people who live in flatland. People who live in flatland have left and length and width. They have no depth. We have depth. We have thickness. In physics class, you will see equations that look like this. Oops. X, Y, and Z. The X will stand for length, the Y will stand for width, the Z will stand for depth. Everything that you do has a force. If I hit Brandon in the head, there are three components to my punch. A length component, a width component, and a depth component. Every force in nature that you'll see in your physics class will be described with an equation like that. That's why we do this stuff, so that you can do it somewhere else. Let's finish this off. Sometimes competing with conversation. I have nothing to combine with 2p squared, nothing to combine with 5p, but I did have a 2 cubed and a minus 8 cubed. That gave me minus 6 cubed. The plus 1 I had nothing to combine with, so I just wrote it down. That's as far as you can take it. Over here, I had 6x squared. It takes care of that. I have a plus 4x, and I have a plus 6. Yes, sir. I was crossing them out as I used them. That helps me because we had a 4x squared and a 2x squared. This was just adding. Ethan, one more time. What do I do when I've circled something after a subtraction? Change to opposites. So the beginning looks the same. If I'm subtracting all of that, I'm changing all of it to its opposite. So minus 1 becomes. Now you just combine like terms. 3x squared minus 3x squared.
Negative 7x. Oh, that means 0.
How about 0?
Yeah, 0. How about
If
0?
That's 0. How about minus 2x minus 5x?
That's
Negative 7x. That's what I was trying to say.
Done. That's as far as you can take that problem. Last one, I see x squared and x squared.
2x.
2x squared. Have I done anything with the exponent? Resist the urge to take the 2 and the 2 and add them together. That's what we're going to be covering next class. Right now we're just adding up apples and oranges. 1 apple plus 1 apple is not an apple squared. It's just 2 apples, right? Sure? Do I have anything to combine with 2xy? Do I need the 1? No, but I can keep it there. It's not wrong. Y squared minus 2y squared.
1y squared minus 1y squared.
I can put a 1 in there if I want. Please take out this worksheet.